Hello, and welcome to your final computer science lesson for the semester. Today we'll be going over data structures. We'll give you a brief introduction of data structures, and then we'll go over three common data structures: arrays, stacks, and queues. Data structures are used to store and organize data so that it can be used efficiently. There are three main operations when working with data structures: adding, removing, and accessing the elements within the data structure. The first type of data structure we want to talk about is arrays. Arrays are of a fixed size. That means once you create them, they'll have the same size the entire time that your program runs. In this case, we have an array of size 5. Elements in an array are indexed starting at 0. That means the first element in the array starts at index 0, followed by the second element, which is at index 1, and so on. To declare an array, we declare it as shown on the first line here. We have an array of integers, num array. We declare it saying new int, and then we specify the size in square brackets. In this case, we are declaring an int of size 5. Now this integer array already has 5 elements in it, but to make sure we know what they are, we want to set them explicitly ourselves. So in this case, we enter the elements 2, 4, 6, and 8, and 10. To access an element in an array, you simply need to specify the index within square brackets. As we have shown here, you can print out index 3 of this array using num array with a 3 in the square brackets. Stacks are dynamic in size, which means as you add elements to them, they will grow. Elements are added on top of each other within a stack, and you can only access the topmost element. When you remove elements from the stack, they are removed from the top of the stack. To declare a stack, you simply need to declare the stack data type, along with what data type it will actually contain, in this case, integers. We've named our stack numStack, and we just declare it as a new stack of integers. The following lines, we push the numbers 2, 4, 6, 8, and 10 onto the stack in that order, just as we showed on the previous slide. To access an element of a stack, we can use the element at function. In this case, we are accessing the element at index 4. To remove an element from the stack, we can use the pop function. So in this case, we're going to pop off the top element. The top element of our stack is the last number that we pushed onto the stack, which in this case is the number 10. Queues are very similar to stacks. They are also dynamic in size and will grow as you add more elements. But the difference between stacks and queues is that elements are added to the back of the queue instead of onto the top of a stack. When you want to remove elements from the queue, you dequeue them from the front. To declare a queue, it's very similar to declaring a stack, except that in this case our data type is of queue, and similarly we declare our queue to hold data type int. From there we can add our elements to the queue in any order that we want. In this case, we've added the elements 2, 4, 6, 8, and 10. To access a specific element within our queue, we can use the element at function just like we did in our stack example. In this case, we're accessing the first element, which is at index 0. In this case, the number 2 is our first element. If we want to remove an element from the queue, we use the dequeue function. Again, since the first element we added to this queue is the number 2, this will be the number that will be removed.